432 Park Avenue. 432 Park Avenue is a super slender structure that houses luxury apartments in Manhattan, the most expensive area in New York City. Being 425 meters tall, it is the tallest residential building in the world and has the highest roof in New York.
432 Park Avenue is not a conventional skyscraper. It is unusually slender, which means that the width and length of its base are very small in comparison to its height. New York City defines a building with a 1:7 ratio as a slender building. The slenderness ratio of 432 Park Avenue is 1:15.
So, how is such a tall and thin building constructed?
In this video, we are going to demonstrate how architect Raffaele Vignoli, designer of the walkie-talkie in London, and engineers Sylvian Marcus, director of building structures at WSP, designed a super slender residential building in a crowded and very expensive area of New York City.
Manhattan is famous for the Central Park, the financial district, and the skyscrapers which dominate the distinctive skyline known from Hollywood films. WSP built many recognizable skyscrapers in New York alone, for instance One World Trade Center.
So let's check how the structure of 432 Park Avenue Tower works.
The primary structure, which carries the main load to the foundations, is composed of a central core and concrete frame. The centralized core, made of 760mm thick concrete walls, is thin for a tower of this height because the external frame takes most of the loads. The frame consists of beams and columns that become deeper towards the base where loads are concentrated.
The concrete floor slabs are the secondary structure, transferring loads from internal areas to the primary structure. The huge 3x3 windows fill the voids between columns and beams in the facade to form the tertiary structure.
Every material has an ultimate strength capacity. For the concrete shown in this test, the failure occurs at 38 megapascals. The concrete used in 432 Park Avenue has a compressive strength of 96 megapascals. This is over twice as strong.
This test shows the compressive strength of concrete. However, this material is very weak in tension.
On the other hand, steel is very strong in tension.
By using concrete with steel reinforcement, the structure can use both materials to the best of their abilities.
Even with this system, the slenderness of the tower still makes it vulnerable to swaying in the wind. To increase the stiffness of the structure, a large amount of steel reinforcement are present. The reinforcement bars in the columns are 6 centimeters.
In addition to vertical loads, towers also have to resist horizontal forces, like wind forces, for example.
Most towers have a central core that resists these forces, just like this ruler. In order to remain as slender as possible, 432 Park Avenue uses 2 tubes. This allows the central tube to be much smaller. However, the external facade consists of a series of rectangles. When a rectangular frame is pushed from the side, it deforms. This effect, known as racking, is resisted by the reinforced concrete connections between the beams and the columns that prevent rotation. To provide more stiffness, the frame is connected to the core using floor slabs which transfer loads between the two.
In Manhattan, hard marble rock is found at shallow depths. This provides an ideal founding condition for the tower.
The core and frame footings bear directly onto the rock, with anchors drilled 26 meters deep. A tower this slender will not be capable of resisting the wind loads without special measures. This is because when wind blows around square shapes, it creates a large pressure difference that exerts large forces on the tower.
To reduce this effect, 2 windowless levels were added every 12 floors to allow wind to pass through the structure. These floors are not habitable, but are used for building services. These are housed in a cylinder to further reduce the wind effects.
The main issue with the wind is that it causes the tower to sway and resulting acceleration causes the occupants to feel uncomfortable. To reduce the rate at which the structure starts to sway, 2 measures were taken. Firstly, the floor slabs in the top half of the tower were thickened to increase the overall weight. Secondly, 2 650-ton mass dampers were installed at the top of the tower. As the tower sways, the dampers move at different speeds to dissipate energy and reduce the motion. When buildings are much higher than their surroundings, they can bring the fast-moving winds down to the ground level. This effect is known as downwash. The open surface stories help to reduce the effect of this by disrupting the flow. At the building entrances, there are small canopies that protect people entering the building from strong winds. The anchorage provides the foundation with movement resistance against lateral forces.
The project started in 2006 when the 21-story high Drake Hotel was acquired by a client for $440 million. The hotel was world famous and often hosted rock stars such as The Who and Led Zeppelin.
In 2007, the hotel was demolished to make the way for the 432 Park Avenue. After demolition, the bedrock was excavated to create a 18 meters deep basement and foundations. Now we are going to show you the process to install the foundation anchors.
26-metre deep holes were simultaneously drilled and filled with grout, which is a fluid form of concrete. Steel tendons within a sleeve were placed in the grout. A plate was placed on the surface to hold the tendons until the grout hardens. Tendons were stretched and reinforced concrete footings were connected to the plate. The rest of the structure is tied to the footing using steel rebars.
The construction process of the reinforced concrete core and frame took 3 years. Firstly, a timber formwork was placed starting from the ground level. Then steel rebars were installed and the concrete was poured in the formwork. The regular repeating geometry of the tower allowed the slip forming to be used.
The formwork was customized for the scheme. It includes 4 working levels and storage capacity for the next floor up to improve efficiency. This allowed to cut the labor by half, making it a safer site with less people working there. The widespread use of in-situ concrete also reduces the amount of different trades on site and avoided the lifting of heavy pieces, enhancing safety.
The protective net was wrapped around the slip formwork to prevent objects from falling and providing a safe working environment for the workforce and pedestrians below. Similar netting was placed over the windows as the construction progressed.
The building's shape is influenced by New York planning requirements. By using a smaller area of the plot, the developers could build higher, as height restrictions are defined by an average. With increased height, the apartments offer better views over the city.
432 Park Avenue is visible from all areas of the city. Depending on your personal opinion of the architecture, this could be seen as positive or negative thing. Although the building is one of the tallest in New York currently, there are numerous buildings planned of similar or greater height. Therefore, in the future, this tower will blend into the surroundings more easily.
432 Park Avenue is made almost entirely from reinforced concrete. Out of all the materials in concrete, cement produces by far the most carbon emissions. 8% of global CO2 emissions come from the cement industry. For improved sustainability, the concrete mix had 70% of the cement replaced with constituents of clay soils with a much lower embodied carbon. High quality concrete finishing avoids the need for surface cladding on the building facade.
The tower is identical on all 4 sides. Although this goes with the architectural strategy, it does not consider the position of the sun and the effects of heat gain. Solar shading should provide a better environment solution, but the associated wind effects may make them invisible.
432 Park Avenue helps reduce the length of ducts in the mechanical ventilation system and thus the electrical energy used by having air intakes at each service floors rather than the ground floor.
The choice of in-situ concrete for the frame required consistent pumping from street level up. Bearing in mind that the tower is 425 metres high, this gives an idea of the amount of energy required. The transportation to the site contributes a large amount to the total embodied carbon of the project. The total volume of concrete used was 53,000 cubic metres. This would require nearly 9,000 deliveries to site from a standard size cement mixer. Furthermore, in order to get such large, high-performing windows, a manufacturer in Austria was chosen. Over 4,000 miles is a huge distance to transport one of the main components of the building.
432 Park Avenue will never be more sustainable than ground-level buildings due to the height. The energy involved in moving people, water and other services vertically is simply enormous. Yet, when new buildings are needed, building upward is often preferable to a city extending outwards into the countryside.
Unfortunately, it is unlikely to reduce the need for housing in New York. It is estimated that on average only 1/4 of the apartments will be occupied at any one time, and most of the spaces will be bought as an investment. Building a tower of this scale for such a low occupancy level rather than a place for permanent stay is highly unsustainable and sad.
In the tower, the same material is used for the exposed and the enclosed structure. Externally, the repeating concrete structural frames forms the facade of the building and matches the architectural intent of echoing the grid layouts of the city.
The mix of concrete was especially prepared to give a smooth and white finish desired by the architect.
Internally, one of the key architectural intents was to maximise the views. Diagonal bracing, which would have obstructed the windows, was avoided by using a rigid concrete frame system. 432 Park Avenue set out with the aim of creating luxury apartments with incredible views of New York City. The large feature windows, the column-free spaces, and the tall nature of the building have all contributed to the building's success in this area.
Being such a new tower, if there are any problems, they are unlikely to have become apparent already. One issue could be with the fair-faced concrete facade. Without proper maintenance, staining could ruin the appearance of the tower.
Have such large windows on all sides of the tower is likely to create large amounts of heat loss in the winter and overheating in the summer.
The current double glazing could be replaced with a more highly insulated system. All windows sit within the structural frame. This is much deeper than the windows themselves, so the total thickness of the windows could have been increased to improve the thermal performance of the glazing.
The current building only has 104 dwellings and has appropriate services for this level of occupancy. Despite the column-free floor layout, it would be difficult for the building to serve more people in the future due to there only being 5 lifts. We suggest that more lift shafts should be added to provide a better long-term plan for this building.
Personally, I like the tower itself. Its super slender appearance provides interest to the New York skyline and is the exciting beginning of many similar skyscraper types. The tower has a simple regular facade compared to most other skyscrapers. Having this simple layout has created functional and economical internal spaces.
I dislike the tower because it degrades the New York skyline context by dominating and densifying it excessively. The choice of structural form and functionality are very sensible. Yet, I disagree with its proportions. It also triggers a new trend of pencil towers construction that will soon flood Manhattan.
I think it's good to see the structure playing such an integral part of the architectural intent. The downside is that the building emphasizes the real-life game of Monopoly in New York City. The gap between the super rich and the poor people is highlighted with the super slender tower in Manhattan. Well, 432 Park Avenue is dividing opinions. What do you think?
What do you think?